it was a proof of concept, an MVP, the perfect example of an MVP. It was duct taped together, some hastily 3D printed shells, which were mismatching filaments, none of which was really waterproof.
Welcome to How I Fixed It, a podcast where we cut the noise and learn step-by-step strategies entrepreneurs use to grow. I'm your host, Madhav Malhotra, and today I'm lucky to be joined by Sam Dugan, the co-founder of Vision Spatial Technologies. Sam is an engineer working on detecting accidents at recreational facilities like ski resorts. I'm very excited to learn more about his company and his unique skills with build, measure, learn cycles and MVPs. Thank you so much for joining me today. And the first thing that I'd love to ask you about is who you are and how you got started with your company.
So I'm Sam Dugan. I'm a 3B mechatronics engineering student at the University of Waterloo. And I took a little time off between high school and university. I actually moved out to Whistler, BC, where I lived for 4 months. I technically had a job, but my job was being a professional photographer on the hill. You see, I love skiing and I spent every moment that I could on the hill. But over the course of the season, I saw so many people getting injured on the hill, and a lot of my friends as well. It gave me some time to reflect on, the risks of skiing and how it is a high-risk sport. And once I came to UW and started pursuing my engineering studies, I kept trying to reflect back and think about how I could use my engineering intuition to solve some of the problems that I saw on the ski hill, to make the sport safer and to make it more accessible to more people. So that's sort of when I started doing a little bit more research. And one of the biggest problems that was clear to any skier that's of a certain skill level is in the terrain park, when you are standing at the top of a bunch of jumps looking down the hill and you don't see the landing zone of any of these jumps you're about to hit. So it's a completely blind landing zone. You don't know if the person who went before you skied away or fell, now posing a threat to themselves and anyone following you or following them over the jump. So it has a huge risk of collision, and that's how injuries are caused. So I set out to make a device to help try to make the world a safer place to play.
Could you tell us more about that device? What is the big product at VS Tech?
Okay, yeah, the Smart Patrol is a versatile, mobile, real-time computer vision powered platform for monitoring blind spots in recreational applications. So in the skiing application, we put the Smart Patrol on the top edge of the landings so that they can monitor the landing areas for any hazards or people that shouldn't be there. And basically, it's a pole-mounted system which just sticks in the snow. And at the top, there is a camera which captures live video of the landing zone. And that's fed to an onboard processor, which then runs proprietary real-time computer vision algorithms to determine if there's anything in the landing zone that shouldn't be there, anyone or anything. And that's then indicated to everyone uphill with either a big green circle or a big red X. And that is how everyone knows whether the jump is clear to hit or not.
Yeah, it's really cool to hear about the potential idea here. What were some of the tests involved that allowed you to understand, is this a good idea to go deeper into? And how did you transition from, just testing out, is this a nice idea? Could this be feasible? To now starting to seriously improve upon the product?
Sure. So as you briefly touched on there, my first intentions with the project were just as a side project. I was at the time in my co-op, my second co-op, and I had this idea of basically an automated traffic light for ski jumps. And I had never seen anything like it, so I decided, hey, it would be cool to learn about computer vision and try to see if I could make something like this work. And that's just what it was, an experiment initially. And I pursued that for about a month until I sort of realized, hey, this actually could be something. It actually works. And that was the point at which I decided, hey, maybe I should actually seriously consider about taking this thing further. So my next step that I pursued was really getting a mentor to sort of advise me through some of the next steps, the reaching out to the first customers and all of that. So I was fortunate enough to have a friend of the family who's also actually an adjunct professor at the University of Waterloo, Dean Pacey, who has been a great mentor to me all right since the beginning. I reached out to him, went over to his house. I think I went over at like 8 p.m. or something like that. And we were talking past midnight. It was a huge brainstorming session talking about the possibilities of what this could be in the future. And after that discussion, I reached out to one of the ski hills, Mount St. Louis Moonstone, which I and Dean had identified as one of the potential prime candidates for the technology. And we were fortunate enough to get a reply. And that's when Dean and I sort of refined the technology a little bit more and went and met with the owners of Mount St. Louis in person and showed them the technology, what it was capable of, got a whole bunch of feedback. And that was in early March. So I started working on this project at the beginning of November. I met with Dean, got an advisor a month and a half later, mid-February, reached out to Mount St. Louis end of February and met with them early March. And based on all that feedback from that meeting, we decided to do an on-hill test of the technology for the very last weekend that Mount St. Louis was open that year. And it was the March 30th and March 31st. And so I had basically at the end of 3 months from starting the project, I had a test on the hill.
Yeah, that's really precise. Could you tell us more? How did the test go?
The system looked completely different from what it does now, but it was a proof of concept, an MVP, the perfect example of an MVP. It was duct taped together, some hastily 3D printed shells, which were mismatching filaments, none of which was really waterproof. It had a flap over the screen to keep the water off of that. It was pouring during the tests, and it was too dim. You couldn't see the light for more than probably 20 feet away. The camera on the pole was not really adjustable, so it sort of only looked in one direction. It was full of flaws, but those were the flaws that really helped inspire the next generation. Design is iterative, and after that, I spent the whole summer redesigning the system completely from the ground up to be better, faster, stronger, you name it. And I designed it with the goal of manufacturability and scaling in mind. And it was 100% the feedback and results of that initial MVP test, which told me the areas that needed to be improved. I would have had no idea what to make better if it had not been for that initial site test. And after a long summer of redesigning, I was able to put together what I called the second generation of Smart Patrol. And that was the system that I first approached Mount St. Louis back in, I guess it was September of that year, with the goal of selling. And it wasn't until I think November, technically, that we were successful in coming to an agreement for the sale. But that was the very first commercial deployment right there.
Wow, that is some really fast progress. I'm actually curious about one part of that story. Could you expand a little bit more about how exactly you figured out which improvements needed to be made over the summer based on your MVP results?
Yeah, I have a very funny story about that. Nothing goes quite as planned. So, in these early days, I was actually using a Raspberry Pi as the guts of the very first generation of Smart Patrol. Unfortunately, my Raspberry Pi was not well. It wasn't impossible to connect to the internet. It was just difficult, and so I was not using any backups of any sort for my code. So I guess it was the night before I was to do my first demo at just the meeting with the owners of Mount St. Louis. I lost all my code because the Raspberry Pi, the SD card fried basically. So all the data was lost and all the code was lost as well. You would have thought I learned my lesson, but apparently I didn't. In the rush to get things going again, 2 nights before I did the on hill demo, the Smart Patrol SD card burnt again. At that point, I was able to identify the cause of the issue. It was actually that the casing that I had designed to 3D print on that around the enclosure basically was actually hitting and snapping the SD card in half when I put it together and effectively ruining any data that was on there and making it definitely irrecoverable. So I had pulled a couple all-nighters in order to rewrite all of the code just to the point where it was good enough to test it or to show it before these critical deadlines. And that's what I have to do or had to do in order to just make it work. But that didn't answer your question at all. I thought that was just an interesting story. Regarding your question, yes, there were only 2 days to get all the data from. And although there was also a tremendous amount of feedback from not just the technology, but also the people around it as well. Some of the most valuable feedback was from the public, the skiers that were interacting with it on the hill. Did they follow the light? Were they, interested in what it was? Did they understand intuitively what it was there for? And the answers were yes, yes, and yes. The public reaction was surprisingly positive. We expected there to be pushback, but overall, people were very enthused about the technology, which was perhaps our biggest indication as to go forwards with this. And then, based on the feedback from the resorts, we determined that there was an actual market for this. But at the same time, we determined that in order to be a viable product for the approximate price point we could offer it, we had to change our value proposition. So the very first generation of Smart Patrol was just a traffic light. It was just a simple green red light. It wasn't connected to the internet. It didn't have any other flashy features. It just was a traffic light. Based on all the feedback from the resort, we realized that there's actually a need for a lot more functionality. So they were interested in seeing some of the photos from all the crashes for liability reasons. It's important for them to know when people crash. So if someone does come to sue them, there is something that they can prove to show what happened. And so that's an example of us having to change our product based on the feedback. And those are the sort of changes that I made over the summer. Additionally, we also added statistics gathering so that the resorts could see how many people are actually using their jumps. That's how we modified it based on the feedback.
Yeah, that's really cool to me, especially because I'd assume, you've seen the problem firsthand, you've been out on the hills, you would know what needs to be improved, but as you mentioned, even still, you had room to learn and to explore new perspectives based on the conversations you had with the ski hill owners. And regarding those improvements that you could make in the product afterwards, how did you get into the constant cycles, I guess, of continuously improving this or that as you got ready to commercialize the prototypes?
Well, that cycle started well before November. Over the whole summer, I was working a job at the time, a full-time co-op, but every evening I was living on my own at the time, so I had absolutely no obligations to anyone except myself and my project. And so I spent the summer iteratively designing the whole system as well. One of the biggest problems was making the system waterproof. I had to basically modify an existing enclosure and find a way to make the seals around it waterproof still. And that was an iterative process that I had to do just through testing because I couldn't make it just one waterproof unit. I had to make it a repeatable design that was waterproof every time I printed it so that when I made more of them, I knew that they would last. And so that was something I struggled with. It was a matter of making a design and then printing it, testing it, and based on those results, it's leaking over here, it's leaking up here, it's leaking on the back, on the front, around the LEDs, and making those modifications and then testing it again. And just because of the way I was sort of set up here, I basically had a 1 week lead time on all my 3D printing stuff. So I ended up in this 1 week cycle, which was the build, measure, learn cycles. And it allowed me to iterate all aspects of the design basically once per week. And over the course of a summer, where you have 16 weeks basically is 4 months, I could make a lot of modifications. Now, I didn't have to modify every single part every week, but I would modify them until they basically met the requirements I had of them at that point, whether it be waterproof, mechanical durability, whatever. Come November, once we officially commercially deployed on December 1st, it was the exact same thing, just on the hill. At that point in time, I was actually in school. So I was doing this in the middle of exams, not something I would recommend. But I basically had to go to the hill probably a couple times a week, take a look at all the units, figure out, if anything has broke or what, and basically go back, come up with a solution to make it better so that it wouldn't break again, and then print it, and then go back to the hill, reinstall those upgrades, and then repeat. Leave it for a couple days and go back and check again. And doing that during exams dropped my grades significantly. Again, would not recommend that, but it allowed me to stay on top of the issues and make it a product that actually could survive in the environment that it needed to. Some of the things I learned the hard way were that no matter how well you design it, you can't make compliant mechanisms that work in the cold because plastic becomes brittle and will eventually snap. So I had to completely change the way the camera mounted to the pole. And there were issues about when people would place the pole into the hole that they drilled in the snow, where the mass of the things that were attached to the pole basically would jerk downwards and break all the mounting components. So it was a matter of dealing with all these issues as they popped up and then trying to fix it so it didn't happen again. And that's where the iteration came in.
Now, when you were going through these cycles, especially when you also had exams at the same time, how did you find the accountability to keep yourself going, even amidst, say, hard cycles where you didn't entirely know how to fix the challenges you had?
Ooh, that's a good one. I think that's kind of one of the keys to being an entrepreneur is that you just have to have your own answer to that very question. You can't make a company if you're not motivated to make it happen. For me, I wanted to see this through, so I had the drive to just make it work.
Yeah. So just a you thing, like, did you have any check-ins with your mentor that kind of gave you the fear, like, I better get this done, otherwise I don't have anything to show him?
uh, a little bit. I think definitely it helps. I think the big thing was I had a deadline in mind of sort of the end of the summer was when I was going to go show this to Mount St. Louis. And that's when I had to have something that worked. So I made sure I did at all costs.
Mm-hmm. And what did you do when you did have those cycles where you knew what the problem was, but you weren't exactly sure how to fix it, and maybe you felt a little bit stuck when it came to moving forward?
Yeah, the one of the best examples of that was just the wireless situation. LTE is expensive. We didn't want to go to LTE. I tried, or I was looking at every other option in the book, and I talked to several people who I knew more about this than I did, and I basically wanted to know. Actually, at that time we weren't using LTE either. We were all on Wi-Fi. And so it was all about how can we make, the Wi-Fi signal strength stronger? How can we receive it from further away? And I didn't know much about that. I I knew you could put tinfoil around your antennas on your router to make it work better, but going into it, that sort of was the my understanding, but like it forced me to learn about it. I had to set out and actually do the research and figure out what technologies there were available to make the problem I had work. And it came down to, well, talking to those more knowledgeable and doing lots of Googling.
And was it helpful to be a university student during those times? Were you able to find people to connect with to solve these problems?
At that point in time, I did not take advantage of the university nearly as much as I should have. Living away from the university up at my cottage at the time, I didn't even really think too much about the university. I was able to draw mostly on my own network. At the time, I had done a couple co-ops. I was midway through my third co-op, and I had made enough connections in the industry that I was able to basically contact all the people with knowledge about the things that I needed to.
Yeah, and that's actually the other big area that I wanted to talk about. So the first one was the build, measure, learn cycles for sure. But then the other thing that really surprised me about your journey was, like, I feel like more so than other people, you just really acknowledge the role of your mentor, and then also, as you mentioned, your other industry connections. So I was wondering, like, if you could share any stories of tough spots that you were in, where maybe your mentor's accountability or your advisor's accountability helped you move forward?
Yeah. So I had the wireless thing mostly figured out. I had the units connected to the internet. Now what? What's the best way to dump data to them and pull data from them? And basically at the time there's thousands of different ways to do it. Just the problem is I had about 100 other things to do, from other mechanical design things to improving the software that ran on the unit. I didn't have the time to really properly build out a website and a backend to take in all the data, and especially not build anything that was scalable. So I had to reach out to some of my mentors, and we sort of came up with a couple options. Actually, at the time, it was my uncle that gave me the advice to basically just run a server in my basement and just dump images to it as basically files. And that's what the Smart Patrol ran on for a bit, because that is what I could scale from. It was organized information, could have been improved, but it worked and it was easy to do initially. And that was what I needed at the time. So that was a perfect example of finding a solution to my problem due to reaching out to my mentors.
Yeah. And did you find that most of the problems you were solving with them, they were like technical problems, or?
Most of the questions I asked my advisors were technical, I think, at least at that point in time. At different stages in the company, sort of your needs change and evolve. Early on, developing the technical solution was the most important, because you don't have a business unless you have something to offer. So at that point in time, it was largely technical questions. But then later on, it shifted to more business, and that's where I've sort of been getting most of my help over the last year, probably, because that's where I don't have all the experience and where we currently have to be doing the most development.
Mhm. And I think my last question for you today is actually around how you like maintain mentorships like that over time. So it's been at least a good 2 years.
Yeah, I think it's important to make sure that your mentors are invested in your interest, and that can quite literally mean sometimes that they are invested in your company. So that's what it was in my case, and I think that I've seen plenty of value from the ownership that my mentors have in my venture. That's one of the ways to do it, at least.
Yeah, that sounds like a rather simple way. Yeah, it's very direct. I like it. So I really appreciate you guiding us through like that first little while. I know there's so many aspects to your story in the year after that that we didn't even cover, and I'm pretty sure you will be starting to scale up your deployments very soon. Is that correct?
As soon as COVID's done, yes, that's the plan.
So it is going to be like quite a journey to watch. If anyone's curious on updates or learning more about the company, where can they go?
They can go to our website at visionspatialtech.com or find us on most social medias.
All right. Well, I'll be sure to link to those sources below, and I know you also have some pages online that I can probably find. So I really appreciate you taking the time today. It is always cool for me. As I said, I just love stories. So thank you for diving into all those nuanced details that really show like the experiences behind why the lessons are true.
No problem. My pleasure.